Hi, good morning.
Good morning.
Good morning.
Hi, good morning.
Morning.
Okay, thank you for coming to our webinar, sample size webinar. So I'm Miss Farhana from Research Training Unit, Research Office, Faculty of Medicine, UM. So before I introduce our speaker today, I would like to cover a few housekeeping notes. The first one is today's webinar is being recorded and I will send the link to you after the webinar is finished, after the event. And the second one is if you have any questions or comments, you can type it on the chat box and we can discuss it after the event, a short discussion after the event. Okay. Okay, today's speaker is Dr. Mahmud Dani. He is currently a senior lecturer from Department of Social Preventive Medicine, Faculty of Medicine, University Malaya. And he is currently person in charge for research, methodology and statistic clinic in research office. So I would like to pass this stage to him. Dr. Mahmud, it's all yours.
Okay, thank you, Farhana. Good morning, everyone. Welcome to our webinar today regarding to the sample size and sampling method, which is one of the, what do you call it, high demand service in my statistic clinic. So the reason that we decided to provide this webinar is because of the feedback that we received during last 2 years in the statistic and research methodology clinic in RMU. This is a common, what do you call it, issue and problem that most of the researcher and the students dealing with. Okay, without any further delay, let's me to share my screen and then we can start. Okay, can you see my screen now?
Yes.
Okay.
Yes, Doctor. Yes.
So today actually it's only 1 hour talk about the importance of sampling and sampling method and sample size calculation and explaining some basic what do you call it, terminology regarding to the sample size and sampling method. In this talk I'm trying to cover some definition of statistical inference, population and sample. I will mention about sampling methods, and finally we will talk about sample size calculation, and also I will introduce you one of the common software regarding to the sample size calculation, which is called G-Power, right? Okay, as you know better than me, all of us, we are dealing with research, and research is a systematic process of investigation in order to establish the facts and creating the new conclusion to solve our problems, right? And basically in quantitative research, we are dealing with the data collection and converting this data collection through the process of data analysis to the information. And of course, we will be able to add to the body of the knowledge by creating this kind of information. But there are many types of research, quantitative research, like content analysis, existing statistic, survey, and experiment. I think in Faculty of Medicine, mainly, most of the researchers are dealing with the experiment and survey, right? We collect data through the clinical observation or databases and do the cross-sectional study or longitudinal study. A part of the research in Faculty of Medicine also involved with the lab experiments, right? And do you know what is the what exactly we mean by existing statistic? What do you think? Any idea? What do you think by existing statistic? Yeah, when we talk about statistic, means meta-analysis and systematic review. So it means you collect data based on the current affairs in that area. Thank you. Okay, these are again just reminding you that any kind of quantitative research methodology involved with several steps. And as you can see here in the step 4, we are dealing with the sampling and collecting data. Of course, after that, we have to analyze the data and then presenting the results. We define the research problems, research design, and also defining and validation of the research questions or instruments. But one of the critical phase in any research process deal with the sampling, sample size, and data collection. And it is very important for anybody who is going to do a research to understand the concept of the scientific concept of the sampling method and sample size calculation. Okay, why do we need to do the sampling? What do you think? Feel free to open your microphone and share. Let's have this feeling that it is a real, what do you call it, interactive area. What do you think? Why do we need to do sampling?
To get a better clear picture about the field our studies.
Correct. Anything else? Do you want to add?
Because we cannot take all elements in the population.
Okay.
It's a fraction of the population.
Okay, why do we need to study a fraction of the population? Because as Boon Seng mentioned, we are not able sometimes to collect the whole population, right? So the problem is that in collecting data or gathering data from the whole population is impossible. Sometimes the population is not accessible or not available for you. And sometimes, even if the population is available for you, it is very costly and time-consuming process to collect data from the whole population, right? So, and of course, in the process of data, in research, always researcher faced with some limitation in terms of the cost and time, right? Of course, if you are able to collect data from the population, your results will be 100% accurate, right? Clear? So means there is no bias. All the results will be up. So there is no any error if you are able to collect data from the whole population. But we know in the real world, it is it is impossible to collect data from the whole population unless your population is a small population. If your population is a small population, you do not need to do the sampling and then do sample size calculation. I will mention about it later. But when you are not able to collect data from the whole population, of course, the alternative strategy is sampling. But we remember the sampling, yeah, it is low cost and it can be done fast compared to the whole population. But results always, when you collect data, your results are biased. It's not 100% accurate, right? And what we do actually in a real study, through the statistical techniques, we calculate this bias. I am sure that most of you are familiar with the term of what do you call it? Let me to share this like, okay. So you know how we can measure this bias? I am sure that most of you are familiar with, okay. So I'm sure that most of you are familiar with alpha, right? Or sorry, the p-value, right? What is p-value? What is the p-value? I know most of you know that if the p-value is less than 0.05, then you say the results are significant, right? And if the p-value is more than 0.5, you say not significant. That's the point. What does it mean when we say results are significant? What does it mean? And when the p-value is less than 0.5, we say the results are not significant. What does it mean?
If p-value is less than 0.05 means in our study there is less than 5% error.
Exactly. This 5%, this p-value actually is the amount of your bias. So means if you calculate, if you do the statistical analysis and then your p-value is, for example, 0.17, then means the amount of your bias is 70%, right? And your confidence will be 83%. And of course, we cannot generalize our finding to the population, correct, when your confidence is less than 95%. So means in a statistic, the cutoff point is 95% or sometimes 90%, right? So when you calculate the p-value, actually you calculate you estimate the bias. And if your bias is high, then you are not allowed to generalize your finding, right? So this is the point that you need to understand, because later I will mention that how the p-value can be affected by the sample size. That is very important, and also sampling method. Remember, we do always sampling to estimate the population, right? Okay, if my sample is biased, then can I inference or can I generalize my finding to the population? No. So that's why we say the results are not significant. This is very important to understand. The term of not significant means we are not able and we are not allowed to generalize our finding to the population based on our sample. And when we say the sample, the results are statistically significant, means the p-value or your bias is less than the threshold, which is 0.05% as a common cutoff point, then you can say that my results is significant, means you are able to generalize your finding to the whole population. Is it clear? Can you hear me?
Yes.
Yes, doctor.
Yes, doctor. Clear.
No sound. I think your system has a problem because other.
Yes, doctor.
Thank you. So now this is this is very simple but very basic concept in a statistic. Correct? So to be honest, I face with a lot of people when I ask them, can you interpret the significance? What does it mean? They are not able. You need to understand the significance can be used if your sample is representative sample. If your sample is not a representative from the population, again, you cannot use the p-value as a criteria to generalize your findings. So how we can select a representative sample, then it depends on the sampling scheme or sampling techniques, right? So that's why it's very important to understand 2.2 concept, how we do the sampling and how many samples do we need. These are two factors affecting on your statistical inference. Later, I will mention about the sampling techniques. As you know, we have two types of sampling techniques, right? Have you heard about the probable sampling and non-probable sampling?
Yes, yes.
Yes, doctor.
So when we talk about random sampling, it means everybody in our population has equal chance to be selected. Okay, let me give you an example. Suppose that I want to do a study regarding the socio-economic status of Malaysian. And suppose that I'm living in a rich area. If I collect data only from my neighborhood area, correct? And then collect data from their income, the asset, and the properties, and something like that. If I collect, for example, 400 questionnaire, correct? And then my results came out, the average income of each Malaysian family is 1.2 million ringgit per month. Is it rational? Can I inference it to the whole population? Of course, no. It's so funny. Why? Because my sample is not a representative sample. Because your sample is not a random sample. That is very important. I faced with some of the students, I faced with some of research done by some of the students and researchers, because almost for last 6 years, I provided this consultation in the Faculty of Medicine, and before that I was in EDEC, and I provided this consultation. And this is one of the issues that I faced. Some of the students or researchers, they did non-random sampling, and then unfortunately, they judge and discuss their results according to the p-value. No, the p-value only can be used when your sample is a representative sample. And that can be happen if you are applying the random sampling. Correct? Is it clear?
Yes, doctor.
Okay, so that is very important. Okay, maybe you ask yourself, okay, if we do non-random sampling, what is the alternative? I will talk about it later. So remember, the p-value or the amount of the bias only can be applicable when you are doing the random sampling. Okay, let's go ahead. Okay, as I mentioned, we have some, what do you call it, the population. You need to understand what is the definition of the population. The population is all the individuals that at least they have one common characteristics in terms of your research objective. They have a common characteristics or common, what do you call it, properties regarding to the research there. And sample is a subset of the population, right? This is all the subject, and a subset or fraction of the population is called sample. So this process, actually, this is the process of the sampling and inference to the population that I already talked about it. You have a population, and then you have a study population, because sometimes this study population also is called accessible population. Sometimes, despite your population is huge, maybe the accessible or study population a bit limited, which is called undersampling frame. Though you do the sampling process, you do analysis on your sample, and then the results can be inferenced to the population. And that can be happen if your sampling is a random sampling. Remember, this is very critical point. So there are some terminology that you need to understand. What is the target population, and then sampling unit and sampling frame and sampling scheme. So this is the, let me to close this one. So again, just to remind you, you need to understand the population, and then the target population, which will be defined by the sampling criteria. Of course, you have inclusion. Most of you define the inclusion and exclusion criteria in your study, right? So this helps you to define your target population. And then after the target population, the accessible population or a study population, and then the sample, which is a proportion or subset of the whole target or study population. And finally, the subjects or individual, right? This is the schematic figure to show all these terms, or what do you call it, the concept in the process of the sampling. Okay, when you develop a sampling plan in your research, please remember, if you're writing your thesis, if you're writing your manuscript, please make sure that you already explain all these 5 steps. First, you need to define the population of interest, right? Okay, second, identify your sampling frame or study population if possible. Then, what kind of sampling you are planning to use in your study? And then 4, you need to also support your sample size calculation based on the, what do you call it, the new techniques like power analysis that I will discuss it later. And finally, how did you collect data, how you execute the sampling scheme or sampling procedure. These are 5 main components that always, when I receive an article to review an article or thesis, always I look at these 5 components. These 5 components should be highlighted and should be mentioned during the explanation of the, what do you call it, your methodology. These are, what do you call it, the structure of the sampling plan for any kind of research. There are many factors affecting on your sampling design, correct? So the first one is research objective. What kind of objective you are, what do you call it? Your objective is exploratory or explanatory objective. So what is the degree of accuracy? Okay, commonly the degree of accuracy that we set our sampling design or sample size calculation is 0.05%. But it can be also changed more or less. Sometimes in engineering, in some field of science, they set their degree of accuracy at 0.1% or even more, I mean, more accurate. But in social science, in human science, the common, what do you call it, cutoff point or degree of accuracy, always we set it at 5%. So your resources. So sometimes you have a limitation, you have a limited resource, funds or money or equipment. The time also is another factor. Suppose that if you want to fulfill the sample size that you have calculated, and at least you need to spend more time. So just give you an example. I had a student from, if I'm not mistaken, from ENT in Faculty of Medicine. When we calculated the sample size for a certain kind of disease, the total number of patients with that disease per month expected to be, for example, 10 to 15, right? So even less, I think. So, but when we calculate the sample size came out 300 something. So means if the student wanted to fulfill the required sample size, at least, if I'm not mistaken, she had to spend more than 3.5 years to only collect the data, right? So sometimes the time is another factors that can be justified. You know, these are the factors that you need to look at it when you are planning and designing your sampling techniques or sampling methods. So whether you have a knowledge about the target population, sometimes the population is unknown. The research scope also, these are, and the last is the statistical analysis that you want to do. So the sample size or sampling methods also can be affected by the type of a statistic, especially the sample size. Later, I will explain how the statistical analysis can affect on your sample size calculation. Whether you want to do the logistic regression, whether you want to do advanced statistical techniques or descriptive statistical or structural equation modeling. So each of these statistical tests needs their own specific sample size. So means if you are planning to apply 5 techniques in your, suppose that you have 5 objectives, and for each objective you want to apply specific statistical test. So for each of the statistical tests, you need to calculate your sample size. And suppose that you have 5 outcomes or 5 variables, then again for each variables also you need to calculate the sample size. So the sample size calculation nowadays is a bit complicated, but more accurate than the classical techniques. Yeah, 20 years ago, 30 years ago, they just use the sample size calculation by using some formula or table. But nowadays, the story changed. So you need to know how to calculate your sample size according to the statistical techniques that you are planning to apply in your research. Clear?
Yes, doctor.
So if you remember, I mentioned about the 2 types of sampling. Yeah, we have 2 types of sampling, basically probability sampling or random sampling, which can be classified into 4 main categories: systematic, convenience, or simple random sampling, systematic, stratified, and cluster. And non-probable sampling, the main, what do you call it, top method under non-probability are the snowball, convenience, quota, and judgment, right? These are the old school classification, right? But remember, there are some new techniques like multi-stage sampling. Suppose that if you want to collect data from the whole country, right? So then it's a combination of all those techniques. So means in the multi-stage sampling, if you want to collect data from a big area, right, like Klang Valley, Selangor, then of course it is not possible to collect data based on the simple random sampling. So it's a kind of combination of all those techniques. That's why, as you can see here, when we do the multi-stage sampling, right? So we need to know about the first or second or sampling units. So we have several stages. So let's look at this example. This is a real study that we wanted to collect data nationwide from the whole country. So we do the multi-stage sampling, a combination of different, what you call it, based on the, as you can see here. So we use in each step some kind of, what you call it, probability sampling. That's why in a stage 5, we select 5 states randomly. This is a kind of cluster. And then from each area, again, we selected, in each state, selected the state, we selected again randomly 5 areas. This is also cluster. This is cluster. And then in each area, we selected 2, what you call it, both rural and urban area. This is a stratified sampling. And then from each area, then again, we selected 3 schools randomly. This is cluster. And then finally, at the last stage, we selected a simple random procedure. Means we collected data randomly from each school because we had the frame list or the name list of all the students in each school. So what I mean, when you are dealing with some huge data collection like this example, then of course the multi-stage is the best. But the multi-stage was not categorized or mentioned in the classical or all the school sampling techniques. So sometimes, especially when we are dealing with some, look at here, the infection disease, or especially those who are involving in the medical centers, there is another technique which is called time location sampling, which is TLS, correct? So, or venue, date, time unit. So that's why sometimes, these are 2 examples. Those who are interested, they can go and select and find these 2 articles. Sometimes you want to collect data across the time at different center, and as you can see here, AM and PM, and then randomly you select some days, afternoon, morning, evening, So this is the way that you can collect data, but of course you are not able to collect data from the whole, because sometimes it is not possible to collect data in the whole days from the morning to the evening, So this is a kind of time, space, or time venue sampling techniques. So this is also was not classified under the, what do you call it, mentioned under the classical techniques of sampling. These are the new techniques in the sampling, especially for those who are involving in the medical center, collecting data in the medical center. So one common techniques for the sampling, especially again in medical field, medical science, is a census sampling. So census sampling means you collect all available data. So most of the students or researcher that they do universal sampling, they do the retrospective study, right? So if I'm not mistaken, maybe 30 or 40% of the students that I met them during my consultation in my clinic, they use the retrospective studies. So they just collected data from the medical records, correct? So, and they define the duration, for example, for last 10 years, last 5 years, and then they collected all available data. So if you collect all available data, then this is called census or universal sampling. So, and now I just want to mention one critical point. When we do census or universal sampling, do I need to calculate the p-value or not? If you remember, the p-value was, the sampling bias, right? So we use the p-value to inference our result to the population. But when you collect the whole population, shall I still use the p-value?
No, you don't have to because
No,
it's all
we don't have.
Thank you very much. Yeah, this is the point. And unfortunately, I shall say that some of the students, they do the census sampling, they study the whole population, and then they do a statistical analysis and then decide and judge their results. They interpret their results according to the p-value, which is totally wrong. When you study the whole population, you do not need to do statistical inference. Yeah, you can do the correlation, but you don't need to talk about p-value. You can compare, you can do the regression analysis, is okay, but you don't need to talk about the p-value. Is it clear?
Yes,
Yes.
Professor.
Yes.
Yes.
That is very important for
Yes,
everyone
okay.
to understand this concept. Because why? This is one of the common mistakes. I receive sometimes journals to review, but it is not only among us. It is a worldwide problem among some of even top researchers. In their sampling, they mentioned that we did a retrospective study and we collected all available data, and then suddenly they try to use the p-value. Maybe you ask yourself, okay, if I do the, what do you call it, census sampling, then what shall I do? How can I evaluate my research objective? Okay, in this case, you do not need to interpret your objective or your hypothesis based on p-value. So what is the alternative? Do you know what is the alternative?
Yes, effect size.
Exactly, yes. So if you study the whole population, then you do not need to judge, evaluate your results, objective or hypothesis is based on p-value. Then we need to apply another criteria, which is effect size. And then I will talk about effect size later. Clear?
Yes, clear.
Okay, fine. No question. If you have any question, just drop your question in the chat box or open your mic and just share with me if you have any.
Dr. Mahmud,
Yes.
just a question. Regarding the time-space sampling method,
Yes.
how does it provide randomness? How do we
Okay.
prove it?
True. It is not a fully random, but we try to make it random as much as possible. For example, so in each center, randomly you select some days. Suppose that you have a limited access to that center, right? Suppose that the administration gave you only permission to go 2 days in a medical center. So you select 2 days randomly. The second day, and randomly one day you select AM and one day PM. This is all random, right? So we try to distribute the time randomly across all different centers. So through this process, we try to make it as much as possible close to the random process. Clear?
Understood. So actually, we merge it with another sampling method. So it's like a extended of a multi-stage sampling, right?
Something like that. But the term that they use it is time-space sampling, especially in medical field.
Okay, thank you, Dr. Mahmud.
You're welcome. Okay, so let me open the chat box. Okay, so that is a good question. If you are planning to do a universal sampling, the minimum time, actually it depends on the field and also it depends on the experts' opinion. So means you need to approach some experts in your area and talk with them. Suppose that if I want to collect data from the medical record for last 20 years, correct? So we need to notice that for last 20 years, the medical practices, the equipment, the techniques there are so discrepancy among these techniques. So if I want to combine all of them, probably the result will be biased. So means we try to homogenize according to the maybe techniques or approach. But regarding to the time period, I advise you to define that time based on the experts, correct? So that can be what you call it, validated by approaching group of experts. Okay, regarding to the calculation of sample size, I will talk about it later. Let's me to finish the sampling method and then we move to the sample size calculation. Okay? Sure, then let's move to forward. Okay, so these are some, for the universal sampling, as you can see here, most of the retrospective study, they use the term of the census sampling. So this, again, this one also was a study in Malaysia, and it was a cross-sectional retrospective study, and then they used the, what do you call it, universal. This is another study, if I'm not mistaken, conducted in Malaysia or somewhere else, the cross-sectional study, and then they use the universal or census sampling, right? And now we move to the sample size calculation. But remember, regarding to the sampling techniques, you, again, just advise you are allowed to use the statistical inference and calculate the p-value if your sampling is a kind of random sampling and you select a subset of the population through the random procedure. If you are collecting the whole data, then definitely you do not need to calculate the p-value. Okay, so let's go to the sample size calculation. So the sample size calculation, this is another common issue among my clients in the statistical clinic. So if I'm not mistaken, more than 30–40% of the students there came to the clinic for last 2 years to ask me how large my sample should be. So this is one of the common issue and problem among the study. And remember, this is also a critical factors. If you want to publish paper, again, if you want to write your thesis, you need to support it based on evidence and statistical calculation. So, of course, the sample size, again, just remind you, can be affected by the time and budget, and also sometimes executive decision, and statistical methods, and also the historical data. These are 4 factors. So these are, I'm not going to talk about these 2 factors, but mainly I just want to focus on statistical methods in the sample size calculation. The budget and time are 2 factors sometimes may limit your sample size. Means, suppose that you collected data. I had a student a few years ago from another university. For one subject, if he wanted to collect data and measure all the variables, the cost for one subject was 2,000 ringgit. If he wanted to follow the sample size calculation based on the statistical method, he needed to collect, for example, 150. So means he needed to pay 300K Malaysian ringgit only to measure the outcome, because he was working on some genome sequencing and it was very costly. So the total budget that they had was 100 something. He was not able to fulfill this 350 sample size. And recently I had another student from Faculty of Dentistry here. Again, the same problem. The total budget that they had was not able to cover the required sample size that we calculated based on the statistic. Sometimes the time also is another factor. So means these are some justification. If you are not able to fulfill the required sample size, then you can justify it according to the budget and time. Sometimes executive decision also. Okay, so these are some limitations, and then let's move to the statistical methods. The data from registry, if you select randomly from the registry, yes, it can be, what do you call it, random. But remember, this depends on that. Where is the hospital or medical center is located? Is it national registry? Is it local registry? Where the location? For example, the correct, cannot be a representative sample from the other parts of the country. So this registry could be only considered as a, what do you call it? For example, the Klang Valley or Selangor, because the probability of having a patient from other parts of the country probably is less. So this needs to be justified according to some other criteria. If you use the whole data, you don't need, because if you do the census sampling from a registry, of course, you don't need to do. But if you collect, suppose that in medical center, in UMMC, in registry, we have 10,000 patients with a certain disease, and you selected randomly, then you can say that my target population, all the patients who has registry, what do you call it, record in the UMMC, and I selected 300, then it can be considered as a random sample. Then you need the p-value. But your population is only all the patients who had a medical record in UMMC. Okay, when we have a target sample size following a correct. Oh. Let me to check the question one by one, sorry. The Helmi asked when we have a target sample size following a correct sample calculation and we have fixed the CI of 96. Can we then still say we have that level of confidence to do subgroup analysis? What do you mean by subgroup analysis? I don't understand.
Meaning that if we have we study, I'm from infectious disease field, we are studying maybe MRSA infection. But after that, we want to actually do a subgroup analysis of only elderly patients above 65 with MRSA infection. But our population is only for MRSA infection for the whole population. But now I want to do a subgroup analysis for only a patient above 65. Can I then say that?
Then you need to calculate the sample size for that subgroups. You know, we have a stratification and a stratified sampling techniques. The stratified sampling techniques we apply, for example, if you want to stratify based on the age, based on the ethnic, it depends on our research objective. If from the first step of your research, you target to study the subgroups based on what do you call it, some criteria like age, gender, ethnicity, then those factors also should be included in the sample size calculation, of course. Then you have to fulfill the minimum required. Okay, for this kind of multi-stage sampling, usually we do the complex sample analysis. And for the complex sample analysis, we have to calculate the sampling weight. And then we apply that sampling weightage during the analysis. It's a bit complicated, but it's possible, yes.
Thank you.
You're welcome. Okay, let's move on because we don't have too much time and I have to cover. It's only a webinar. Remember, this is not workshop. I'm planning to run the workshop very soon. If you are interested, then you can join to the. So for the classical methods for the sample size calculation, unfortunately, still a student used this formula belong to 1960s, almost 60 years ago. Still students use the Cochrane or Morgan table. But I do not advise you to use these techniques anymore because these techniques is old and all the school techniques, and it's not based on the power, and also it's not based on the statistical method, right? So some of the students, they use again this table. This is all the school techniques. So I do not advise you to, this is only for proportion, yes. If you have a descriptive objective to study the prevalence of or incidence of any disease, yes, you can apply this. But if you have any objective related to the modeling, comparison, ANOVA, then it is not advised to use these sampling techniques. Some of the students that I meet them, they said that Dr. Mahmoud, we calculate our sample size based on the web page. Remember this, our web page, yeah, seems to be very modern, but the interface is modern, but the backbone, the formula that they use is still the old techniques, right? So please make sure that you understand the concept of the sample size calculation correctly, and don't just look at the web page. If it's provided by the website, it does not mean that it is an advanced or up-to-date techniques, correct? So before moving to the sample size calculation by the new approach, which is called power analysis, I need to mention and highlight the two types of error in a statistic, right? You know, in the old school techniques, sample size calculation, as you can see here, only the alpha is involved. So the alpha is type error 1, Z related to the alpha value. Alpha is type error 1. What is the type error 1? The type error 1 is a wrong decision when your null hypothesis is true and then you reject it. So this is called type error 1. In most of the old school techniques of sample size calculation, only alpha is involved. But we know we have another type of error, which is called type 2 error or beta. So beta is a decision when your hypothesis is false and you do not reject it and you accept it. So this is called type error 2. This is a typical, figure that we use to show the type error 1 and type error 2, right? So this is called false positive and false negative. So this is the true, the positive and true negative, correct? So this is equal to the two types of error. In all the school techniques, for sample size calculation, only alpha was considered. But recently, the statistician developed and introduced new techniques for sample size calculation based on both alpha and beta. So that's why in the new techniques, which is called the power analysis, for the power analysis, we include also the beta. 1 minus alpha is your confidence. 1 minus beta is called power. Correct? So in the sample size calculation, in the advanced and new techniques, we consider both types error in sample size calculation. Beside the sample size calculation using alpha and beta, also we include another criteria which is called effect size. What is the effect size? Do you know what is the definition of the effect size?
No.
Effect size.
Refer to the magnitude of a significance of the sample towards the population.
No. Because we are not talking about the significance here. Remember, significance only refer to the alpha or p-value. Okay, let's give you an example. This is a typical example that always I use. Yes, you will get the slides after this. The RMC will email you the slides later. I will run a workshop later, in practical workshop on sample size calculation in the maybe next few weeks. The RMC also will inform you. If you are interested, then you can join to the workshop. This is only a talk. Okay, so the effect size actually is the magnitude of difference or correlation. Let's give you an example. If someone asks you, is there any difference between American and Malaysian in terms of the body height? What is your answer?
Yes.
Oh, very fast. Okay, why? Because this difference is an obvious, right? This difference between American and Malaysian is an obvious difference, correct? It can be easily seen. We don't need to prove that difference. Do I need to collect too much data? No. With a few, what do you call it, subject, we can prove that difference. But if someone asks you, is there any difference between Malaysian and Indonesian in terms of the body height? Then it's difficult, right? Then you need to collect a lot of data. If there is any difference, that difference will be small. And to prove that this difference is there, then you need to collect a lot of data. Correct?
Correct.
Yes.
This difference, if we standardize this difference, it is called effect size. Effect size can be used for the correlation or regression or the mean difference. So there are different types of effect size. This is for the difference. So the effect size can be small, can be medium, and can be large. Remember, if you have a non-probable sampling or non-random sampling, then instead of using the p-value, then you just need to interpret your results based on the effect size. Correct? Look at here. Let me to show you an example. Can you see my data, my SPSS?
Yes, sir.
Yes.
This is a very simple, what do you call it, example. Suppose that this is the male and female, and this is the score. I want to compare between male and female, right? So I just want to show you something which is very interesting. If I do independent t-test between the score and gender, I already prepared this one to save the time. So if I run the analysis, the p-value is how much? 0.166, right? Correct?
Yes. Yes.
Is it significant or not?
No.
This difference is not statistically significant. Why? Because the p-value is more than 0.05. Thank you. Yeah, let me to copy paste here. It's easy for me. So now, as you can see here, the mean difference is how much? Among the female is 13.5. Among male is 12 point. How much is the absolute difference? The mean difference between male and female is 0.7. And it is not statistically significant, right? And look at the standard error. What is the standard error? Do you know what is this? What is the difference between the standard error and standard deviation? What is the difference between the standard deviation and a standard error? A standard error is an estimation of sampling error. So look at here. How much is the sampling error here? 4.4 and 2.8, right? The standard deviation is 1.1 and 0.7. Look at here. What will be happen? If I duplicate my data, right? I just duplicate it. And if I do again independent t-test, so can you tell me the results are significant or not? Let me to copy these two tables in SPSS in here. So now look at here. The mean difference, does it change? The mean is same, right? Still the mean is same, right? Look at it. Okay, the standard deviation 1.1 and 0.7 something. But look at the standard error. 4, 0.3. 2.8, 1.9. And look at the p-value. Is it significant now?
Yes.
Yes. But do you think the magnitude of difference change? No.
No.
So see how the sample size affects on the p-value. Of course, if, okay, I had a few students that they collected 1,000, 2,000 data, 3,000 data. Of course, even a small difference will be statistically significant. That is not the point. The correlation coefficient between two variables is 0.07, the correlation. And this correlation was statistically significant. But we know that this correlation coefficient is very weak. So if you look at the correlation coefficient classification, can you see my screen now?
Yeah.
Okay, look at here. The correlation coefficient below 0.2 is a very weak relationship. We don't care about it. Even it's significant. The significance is not our problem because the significance easily can be affected by the sample size. Okay, back to the slides. I don't want to confuse you, but remember, when you have a non-probable or non-random sample, you do not need to calculate the p-value. Instead of the p-value, please calculate the effect size. How we can calculate the effect size? There are groups of family of the effect size. Some of the effect size are common, right? Like Cohen-D, or for the difference, and for the categorical data, the odd ratio or risk relative or risk difference. For the correlation family, the relationship, the Pearson R, the Pearson correlation coefficient, or R squared, or the eta squared, all of them are kind of, what do you call it, effect size. So effect size is not only the Cohen-D. So if you are interested to calculate the effect size for a mean difference, for example, if I go to the effect size, if you go to the effect size calculator developed by Dr. Lee Baker from University of Colorado, if you go to the home page, so this is a very good reference. If you are interested, go to the lecture notes and read about the effect size. Look at here. Suppose that in this study, 30.5, you remember in my study, 30.5, and it was 12.7. The standard deviation was 0.5, and here was 0.71, for example. Then I can compute the effect size. How much is the effect size? 0.86. And considering this guideline, 0.86 is called, it can be considered as a large effect size, right? Sometimes the difference is not significant, but it is large, especially when you are dealing with a census sampling or non-random sampling, correct? So to calculate the sample size in the new techniques, in the new approach, there are several softwares that you can apply. One of the free of charge software is G-Power, like the G-Power. The G-Power is a free software. You can Google it and you can download it. If you look at here, the G-Power, you can search it, G-Power. So the G-Power, if you go to this website, the first website, I mean this website, you can download it free of charge here. This is the manual and this is the software for Mac and OS. When you download the software, you can install it and look at here. There are several statistical tests. If you want to do the correlation and regression, if you want to do the comparison, one test, two tests, t-test, MANOVA, MANCOVA, a lot of statistical tests, and then proportion, you want to do the logistic regression, what do you call it? There are several techniques. And remember, if I want to, for example, to compare the samples, to calculate the sample size for an objective for two independent groups, suppose that the same example, look at here, you need to define the alpha and you need to also define the power. The power is 1 minus beta, 0.8, the minimum power. And this is the allocation ratio. Ideally, the sample size should be equal between two groups. And then whether the test is one-tailed or two-tailed, hypothesis is direct. I will explain these things in the more in depth in the workshop. But there are many softwares that you can use and apply for sample size calculation. The purpose of this talk is just to what do you call it, aware you about the new techniques of sample size calculation. Do not use the old techniques and old schools. Another softwares that you can also download is let me to check it. Yeah, this software is another software, PASS. The PASS software if you Google PASS sample size, this is a very, very comprehensive, a strong software for sample size calculation, but it is not free of charge. You have to buy it, but I think you can start trial version here. This company provided two software, the PASS and NCSS. This is for the data analysis, very advanced statistical techniques, and this is for the sample size calculation. To me, this is one of the best top sample size calculator for many, many kind of statistical needs, right? So, of course, if you just Google, for example, suppose that if you want to do the structural equation modeling, SEM, sample size calculation, then you just Google. There are many online, what do you call it, sample size calculator, which work based on effect size and based on the power. The power means 1 minus beta. So remember, when you calculate a sample size, make sure that these two concepts also are applied in the sample size calculation. One more thing, this is another issue. Some of the students, remember, when you do the sample size calculation, suppose that you want to compare between male and female. Correct? And suppose that you have the quality of life, you have stress, and you have some other factors. For each of them, you need to calculate the sample size. So means the comparison between male and female, you need to calculate the minimum sample size for each outcome. And then you remember the final sample size should be the largest number to cover all the other, what they call it, factors or techniques. Suppose that you have 3 approaches. You want to do the correlation, you want to do the regression, and you want to do the comparison. And you have several outcomes. You have to calculate the sample size for all of them. And then they take the highest number. Okay, so that's all for today. I tried to highlight the most important issue in sample size, and of course it is not, this webinar is just trying to share some points in the sample size calculation and sampling methods. Yes, it is similar to the detectable difference. Yes, this is correct. And the Cohen did. Okay, we have another 10 minutes extra time for Q&A. If you have any question, please feel free to drop your questions. And if you don't have, let's finish the meeting.
Good morning, Doctor.
Good morning.
I have a doubt. For example, in our study, the main objective is the prevalence, to identify the prevalence of particular thing,
Right.
population. And the sub-objective or the secondary objectives, we have to identify between particular group, and we want to identify blah, blah, blah. So the secondary objective, we use a chi-square test. But for the primary objective, we use a descriptive statistics. So in this scenario, how we will do the sample size calculation?
You have to do the sample size calculation for both objectives. As I mentioned, the sample size calculation depends on the number of the variables that you are using in your research, and also the number of the type of statistical test that you are applying. Of course, when you have main objective or second, okay, let's me to share with you something that maybe I forgot. You remember this sample size calculation, this formula that I told you, it is an old techniques, but still it's applicable only for the prevalence, right? So for the prevalence, still you can use it. So if you go another calculator like OpenAP, still OpenAP, you can use this sample size calculator for the prevalence or incidence. But look at here, this is OpenAP for proportion. As you can see here, documentation, if I go to the documentation, then you can see here. This is the same formula. This is actually, it's adjusted the same formula, but they add also the design effect. We will talk about these things in the workshop in details, but the same formula. For the descriptive, if you have this, but remember, this is only can cover only one descriptive objective, which is related to the prevalence. But if any other objective in your research, like chi-square, regression, you need to calculate the sample size accordingly.
Okay, thank you. Thank you very much.
You're welcome.
Hi, Dr. Mahmood. Can I ask, what about machine learning type
Yeah,
of
I saw your question. Actually, for the AI and machine learning approach, there is no actually, because it does not work based on the statistic, right? Because in machine learning AI, it is not works based on calculating the p-value or power. So it depends on the, and I think for the AI, some of the techniques works based on the data simulation, right? I did not see any guideline for sample size calculation for the AI, because at least based on my limited knowledge, I couldn't find any guideline for sample size calculation for AI techniques and methods. But as long as you have justification, if you are applying the statistical techniques for any kind of analysis, I think that can be applicable for the AI also.
Good morning, Dr. Mahmood.
I'm searching for that. I try to find your answer very soon. Don't worry.
Okay. Thank you, Dr. Mahmood.
Dr. Mahmood, sorry, I have a quick question actually.
Sure.
If, for example, in effect size that you mentioned, let's say the effect size is extremely large, which is actually 2 point something. Is there an error to cause such a big size? Is it to do with the actual sample size itself being small, or?
Of course, if you apply the large or small sample size, you don't need to collect too much data. It affects on your sample size.
No, in other words, after I've collected the data and I'm analyzing it, and it turns out that the effect size cohency is large.
Yeah, that is another story. Remember, during this workshop, we just talk about sample size calculation. And sample size calculation sometimes only done before running the research. Sometimes you say that the whole data that I could collect, remember the example that I mentioned? I had a student from ENT and she was not able to fulfill the sample size. In this analysis, let me to share something with you. Can you see my screen or not?
Not yet.
Not yet. Okay, let me share the screen. So can you see here, this is the G power, right? As you can see here, we have post-hoc test, right? So the post-hoc test is what they call it, the kind of reverse engineering. So means sometimes you have a limited sample size. Suppose that they collected 23 male and only 12 female. This is all available data that I could collect. So the effect size that you have also achieved in this study was 0.86, right? Then what you need to do, you can estimate your power. So my power is 76, which is not acceptable. So means the possibility of type error 2 is 24%, which is more than 20%. So in this case, if you have a limited sample size, sample, not sample size. In this case, you can do the post-hoc test to calculate the achieved power. Of course, the effect size, if I increase the effect size by 1.2, look at here, again, it affects on my power. So it's a kind of reverse calculation. Could I answer to your question or no?
Yes, actually, thank you so much. Yeah, thanks.
Okay.
Dr. Mahmood, may I ask one question?
Sure.
For social survey, for example, if you want to estimate income, household income, is it necessary we use power analysis to estimate the sample size?
It's a kind of descriptive analysis, right? Because when you want to calculate the estimate the income, correct? It depends on the population. What is your target population? Hello?
For example, for a certain state.
Okay. So for the certain state, if
for
you want,
Selangor, for example.
Suppose that you want to collect data from Kelantan, right? And you want to do the survey for Kelantan, then this depends on the strategy of the sampling. Definitely, if you want to come with the accurate result, you need to do the multi-stage sampling for a huge area, for a large area. So for that one, then we need to calculate the sample size based on the design effect. The design effect, so maybe based on, multi-stage sampling and complex sampling. And of course, for that one, you need a huge sample size. The calculation is a bit complicated. But you need to do the complex sampling, and sample size calculation should be based on same formula. I mean, the Cochrane formula, but in the Cochrane formula, let me to share again my screen. Can you see my screen now?
Yes.
Can you see the design effect? This DF design effect. If you have a complex sampling, then you have to enter for complex sampling, you have to calculate the design effect. And the design effect, or DF, is a very, you need again, design effect formula. If you go to design effect formula, you need to collect some more information regarding to the, inter and intra-cluster correlation to be able to calculate the design effect. And design effect affects on the multi-stage sampling. If I increase this, for example, by design effect 5, so the sample size will be, for example, 1009. And you look at here, if I design effect 1, the sample size is only 384. So design effect is a kind of coefficient that can be used for multi-stage or cluster sampling for the complex sampling. And if you want to collect data from a huge area, of course, you need to collect data based on the complex sampling and multi-stage sampling. Okay, so, okay, that's all for today. I hope that I could open a new window in front of you and highlight the importance of sampling techniques and sample size calculation. Of course, it is difficult to cover all the aspects within 1 hour, but I try to just highlight and inform you the importance of this issue. To be honest, many of articles, journals, review papers, they can easily be rejected because of lack of evidence and support for the explanation, right? The scientific explanation for the sample size calculation and sampling techniques. Thank you very much for your patience. Wish you all the best. Take care, stay safe. And if you are interested, please join us in the next webinars under RMU and also our workshops. Good day.
Thank you, sir.
Thank you, Dr. Mahmood.
The Miss Farhana will share with you the slides later after this talk and also the links of the video.
Yes.
Take care. Bye.
Bye. Thank you, Dr. Mahmood.
Thank you,
You're
Bye.
welcome. Have a good day. Bye-bye.
Thank you, Dr. Mahmood.
You're welcome. Bye.
Thank you.